Welcome, I am Radomir from Adash company and I would like to show you how to use the bump test measurement using our VA4Pro analyzer. Bump test is one mode of VA4Pro analyzer produced by Adash. It was developed for situations when you suspect a resonance problem. What is it, the resonance? For every mechanical object, the frequencies exist on which this object vibrates easily and higher than on other frequencies. We call them natural frequencies. You can see this demo rig, which does not vibrate too much. But I do a small change of the speed and you can see much higher vibrations. It is because of the situation when the speed is near the natural frequency. It is very dangerous to operate the machine near the natural frequency because small unbalance can generate extremely high vibrations. The machine can be destroyed very easily. We meet with resonance problem usually on the machine frame. When the machine speed is near the frame natural frequency, then we measure high vibrations without visible reason. The maintenance guys usually do all standard procedures like balancing, alignment, bearing mounting check, but vibrations still remain high. The resonance problem is the reason. When we measure the vibrations on many points on the frame, then we can draw the shape of the frame. Each arrow is proportional to vibration level in points. I use the steel beam for demonstration. You can imagine what it is the frame. I use the standard accelerometer 100 mV per G and the hammer. I run the bump test. I have to enter the channel used for measurement and number of hammer hits. It is something like number of averages. More hits means better graph. Usually the 4 is good value. I save the setup and next screen appears. We need to teach the analyzer about the vibration level which we made by hammer hitting. I press start and I make several hits and then I press stop. In the next screen, the analyzer is waiting for first hit. When I made it, the graph with natural frequencies appeared. I make all required hits. Let's look at the graph. The natural frequencies are on frequencies where the peaks are. It means 100 and 280 Hz. If the operational speed is near any of these frequencies, then very probably the resonance is the problem. The moving of the natural frequency is the solution. We reinforce the construction in order to move the natural frequency. For example, we add another pillar in the middle. Using of bump test module is very simple and also the beginner can do it. But sometimes we may need to measure the response graph directly in analyzer. Now I show you how to do it. Firstly, I have to set the amplitude trigger level, global and trigger settings. I set the trigger mode to single and trigger source to free run. I run the analyzer and set the time signal measurement. The unit of the measurement must be the same as sensor unit. For accelerometer I have to set the G. If I set millimeters per second, then the signal would be integrated and it is not a good idea for transient hammer hits. I set the signal length to several seconds. I need to have the time for hits making. I press start and I make several hits. I look to the signal amplitude. I can see that the maximum value of hit is roughly 5 Gs. Now I set the triggering. I set single trigger mode. The trigger source I set to amplitude. The pre-trig to 25%. It means that the hit will not be on the beginning of graph. The amplitude trigger channel must be my channel with sensor. It means the first channel. Amplitude trigger level I set to the 20% of reached maximum. I set 1 G. And save. Now I create the new spectrum measurement. Again in Gs. The range I set to 400 Hz. I set the window to exponential. I make the first measurement. I should tell you that in practice the graph will not look so nice. Additionally, I need to set the time window. I press Graph Properties and set View to Time and save. The time signal appears on the screen. Now I press the up arrow twice and the length function appears on the right. I change the length according to the signal. I can also shift the window in time, but this position is fine. The default position is on the trigger position. I press Graph Properties and set View back to Amplitude and save. But now I see the old spectrum. I have to make new measurement for applying the exponential window. I press Start and I make hit. And here it is the final result. The graph with natural frequencies. I can see the same frequencies as in the bump test. Every mechanical object has its mode shapes. I explained it on this simple free beam. The first mode shape is this. We can see 2 nodes and 3 antinodes. Next mode shapes have more nodes and more antinodes. But now I use only the first one, which natural frequency is the lowest natural frequency from the graph. Now I mark several points on the beam. The first measurement is with sensor on point 1. The amplitude on first natural frequency is 1 G. I draw it to the scheme. Now I move the sensor to the point 2 and make measurement. The amplitude is half G. Next point is number 3. The amplitude is 0.03 G. Next point is number 4. The amplitude is half G. Next point is number 5. The amplitude is 0.8 G. I will do it for all points and I draw the values to the scheme. The length of each arrow is proportional to the value in G in this point. Now you can see the first mode shape, which we have got from real measurements. For simple objects, you can calculate the mode shapes, but for complicated construction, it is not possible. You have to measure it. We analyzed the frame by hammer hitting. You will use bigger hammer in the practice. When the machine is operating, you can also measure the vibration levels in every point. The frame is not excited by hammer, it is excited by operational speed. The vibration levels will not be the same on all points of the machine. Measure all of them and draw the arrows again. You will get the operational deflection shape of machine. To know machine shapes is important for machine understandings. The VA4 Pro contains the ADS mode. It enables you to measure these shapes very simply. The animation you can see on the VA4 screen. In the next example, I show you why it is important to know the mode shape, which is the cause of the vibration problem. I use the shaker and the rubber beam. The first natural frequency is 10 Hz, and you can see the first mode shape. If I need to decrease the vibration level, then I can add the pillar to many places and it will work. You can see that the vibration disappears when I add the pillar here or here. But the second mode shape could be the problem sometimes, not the first. Now you can see the second natural frequency. The location of the pillar is now much more important. When I add it in the middle, then the vibration remains unchanged. I must add pillar here or here, or to use two pillars. This is all I wanted to explain in this video. Thank you for watching.